In this video, we begin our discussion over section 11.6. This is graphing in 3D. This is, for me, the most dreaded section of the whole semester. I'm just not very great at art, so it typically just never looks great. I just hate graphing in 3 dimensions, and I'm sure most of you will too. If you hated graphing in 2 dimensions, then you'll definitely hate it in 3. Okay, so this video will focus on something called a cylinder. This is not your traditional cylinder that you're thinking of, like a Pringles can or a cylinder like a can of soda or can of food or something like that. Even though that cylinder, that shape is is a shape like this, but this is a special name in 3D graphing. So how you can tell it's a cylinder, and once you see a picture, you'll understand more of why it's called cylinder. How I can tell is that equations only have two variables. These two variables will give what we call a trace. What a trace is, it's more of like a contour map. If you heard of that, we're going to deal with some contour maps a little later. But a trace is almost like a brain scan, right? A brain scan, they can do a scan where they get like slices of your brain, right? Where you can see a two-dimensional slice of your brain, and not in 3 dimensions. So what this trace is letting one of your variables go to 0 and seeing, like, if I have a 3 dimensional graph, right? And let's say that's my YZ plane. If I let x equals 0, I could get a shape that's on the YZ plane. And this is a 2 dimensional trace, like a side picture of what the shape would look like. Okay, so that's one thing. They have two variables. This is important because the rest of this section eventually after this video, we'll start dealing with 3. The curve is directed along the axis is the missing variable. So when we have two x, y, and z, we'll have a missing one, and it moves along this, and you'll see what I mean by moves along. It's directed along. And then the curve or the trace does not change along the direction axis, and you'll see what I mean. One thing I do want to point out, if you do not feel solid about what's called a conic section, you should definitely go review. I'm not going to spend too much time going over how to tell something's a conic section in 2 dimensions. If you need help on that, you have an ebook that goes all the way back to chapter 1. Check out 10.1 or Google conic sections. Take a look. Print yourself a cheat sheet. Anything that I feel like that you may need, I will provide for you on your test. I do have something else that I will give. I'll let you guys know later. Okay, so let's deal with an example, and this will help explain everything above here. So one thing I want you to notice, the y is gone. So we are dealing with pictures that are only on the parallel with the XZ plane. So y is just going to be all numbers, and you'll see what I mean. Now, if I deal with that like a y equals 4 minus x squared, first let's determine it's a cylinder, because we need to be able to do that, because you're not going to only be dealing with this. So there are, let's get off the highlighter, there are only two variables. All right, that tells me that is a cylinder. All right, that's helpful because it'll help me know the shape after you guys see all of them. The trace, right, that's that two-dimensional shot of your brain if we're thinking of headshots. Trace is on the XZ plane, and I can tell that because those are the only variables there. And then it's directed along the y-axis. All right. Couple other notes. This is if you can't tell, this is a parabola, right? There's a z to the first power and then x to the second, just like y and x. This is a parabola shifted. Whoa, I don't know how that happened. Shifted, can't spell today. Shifted up 4 on z-axis, just like if it was a y, right? That's what that plus 4 does. You can even think about it this way if you're more comfortable with it. Moved 4. And then it opens, an opening towards negative z-axis. Okay, so we have this shape, and I'll show you what I mean by the the trace, let's do that first. Okay, so I'm going to give you, you should have a picture like this on your handout. If you're making your own notes, I would recommend printing this off or drawing a bunch of these. When I draw them, they never look right. So that's why I have a picture. If I ask you to graph on the test, exams at all, I typically will provide this because I'd like for it to be neat. And I have learned fairly quickly when I let the student do it, it doesn't turn out that great. No offense. So it is a parabola shifted up 4. So here's my vertex of that parabola. This is the conic section part I'm not going over. That's the vertex. I also know it opens down. So I'm going to find my intercepts by setting this equal to 0. 4 equals x squared, which means the intercepts are plus or minus 2. So that's on the x-axis. So that's here and here. And this is the shape I get. I get a parabola. It goes down like that. This is living on just the x-axis. So even though it looks like it's flat to us, it's actually at an angle. And you can try your best if you're artistic to figure out how to make the picture look more and more three-dimensional. Now, we're not done, though, because we've only done a trace. This is the XZ trace. This is what the picture would look like on the XZ plane. But I need the rest of Y. How we do this for a cylinder is I just pick some number. I'm going to pick 5. And I'm going to place this 5 where it would be on my z-axis. Now I draw, and I'm going to do some dotted lines here because I can't do you in a pencil. You would just do it light, but I can actually, let's do it this way. What I do from here is I make my axis. Let's make that a little thicker actually. So I'm going straight down. You would use a ruler, right? Usually this will straighten it out for us, but there we go. Usually you would use a ruler to line this up, right? Line it up perfect to that -5. Or that 5, I mean. There we go. See if I can move it over now. With a ruler, you're gonna do this real quick. So there's that. What I like to do is put that point here. If it'll let me. Come on. There we go. There's that point. And what I'll do is I'll draw my axes the way they look. So I will take, let's do another dotted line. Sorry, iPad's being a bit. And I take this, and I'm going to take that line there. And let's make it smaller. Right. Keep the same angle. There we go. And what I do is I go ahead and draw my axes right there at my new point. So notice that I just moved it up 5. Now I have a new three-dimensional graph there. And I can actually draw a bunch of the tick marks here as well. So like 1 is about there, 2 is about, and you could use a ruler to get these accurate. But I actually have tick marks going that way. And this will allow me to graph my graph here. So I plot 2, and then I know it goes down like this. All right, I can do that same thing. So I'm just going to copy and paste this. You would use a ruler. I put it over here on this 5. You could have picked any number you want. I picked 5 just because it gave me quite a bit of space. And I put my axes over here. Use your pencil. Draw these. It's going to help, I promise. All right. This line I am now seeing isn't very straight. There we go. So I plot my red point over here. Then I keep the 2's, the points where they're at direct. You just use a ruler to get the straight across there. Then I draw this graph. All right. And typically what we'll do is we'll put dotted on this side here with your pencil. to represent that it's on the other side. I don't really care. You can do this. All right, so there we go. The green is not part of it, it's just a reference. And then this is the cylinder part. What happens here is that as soon as I can get that to go over, is we actually extend it. Let me draw a straight line here. There we go. It extends along these points to give us the three-dimensional look. Let me do one more. And I actually have a 3D grapher to help us visualize this. All right, so as you can tell, you can try to visualize it. It is a parabola that is extended along, and this is the directional part, is it's extended along Y. We get a bunch of the same shape printed over and over across, and it goes forever in the Y direction. Okay, so I have a three-dimensional grapher. It's free. I use 3D. Oops. And let's not do that. I use 3D GeoGebra. It's free. GeoGebra. I'll show you what that looks like. I think I spelled that right. My spelling has been ruined with texting. So here's our shape in 3 dimensions. You can see it a little better there. It extends that parabola in the Y direction. The Y direction is that green axis, just like that. So that is the picture that we're supposed to be looking at. It's a 3-dimensional parabola like that. All right, so not bad. These are just super annoying to try to be. Particularly if you zoom out, I find it looks closer and closer like the actual picture. All right, we're going to do a bunch of examples in one video. I apologize, this video is going to be longer than the rest, but it just makes sense just to keep going on this one. So let's take a look at this example. First thing we're going to do is make sure that it is a cylinder before I start using this technique. All right, so it does have 2 variables. So that tells me that's a cylinder. It also, the trace is on the XY plane because those are what are there. And then this is going to be directed along the Z axis. So it's going to be running up and down. All right, so the first thing I'm going to do, this is the conic section part. I need to graph this, but that's not in a form that I can recognize. So I'm going to divide everything by 36. I get x squared over 4 plus y squared over 9 equals 1. This is an ellipse with A equal to plus or minus 2 and B equal to plus or minus 3. Where we pick those numbers up is the numbers underneath. Here, the square root. So that is the square root for A. This is A squared. This is B squared. So I get A and B there. And an ellipse, how we do this is we run A along the x-axis and B along the y. It's whatever goes with it. Like this number goes with that x-axis. So let's take a look at our picture. Our x and our y are the flat ones. So what I do is in my x direction, I plot 2 and negative 2. In the y direction, I plot negative 3 and 3. And I get an ellipse. So I will do my best to draw this. There's the dotted one for the other one. And yours may be more, it may look better, actually. So what we do now is I'm going to make new axes in green. And let's move them up, and we can move them up or below as much as we want. I'm just going to move up 5. There we go. And then what I usually do is I draw on here for me. For you, I just use a ruler. Make sure it's parallel to this axis. There we go. You can do tick marks, like straight up. You would use a ruler. All right, so I'm going to mark these. And then I'll erase those green lines. All right, so I'm just making my tick marks here for the x-axis. There we go. So I'm going to erase these green lines now. I have those tick marks. I can also do the same thing here. I guess I don't need to do dotted lines. I can just do normal ones. So you just use a ruler to mark these. You really didn't need all these, did you? We just needed 3. So I'll do this side like that, what I was talking about. I only need this side. So, okay, so I got 1, 2, 3. That's just 3. The other ones don't really matter. I only need that 1 to look good. All right, so I erased those lines now. So notice now I have that shape up here. So I can graph the red graph. I got 2 on my x-axis. I got 3 on the other axis. And then I just do my best to draw. As you can tell, I'm not an artist. This iPad saves me quite a bit artistically. So there we go. All right. We do at least 3. That's what I always do. I'm going to take these green tick marks. I wonder if there's a way. You would just do it again. Let's see if I can copy this. There we go. And I can just set this here. You can set any value you want for your traces. I guess I should do 5. There we go. And then you can grab the actual picture. Let me do these back dots here. They're going to be slightly off, but that's okay. We're not trying to draw the best. We're just trying to get an idea. Oof. All right, so I put those there. That's going to give me that. And I have this one as well. I usually just do the dots. So as you can tell, this is your traditional cylinder running up and down. All right, let me show you a picture of this using the grapher. What I did for that third part is you just put the green axes down there, you make dotted lines with your pencil, and then draw it again there. Let's go to the grapher so you can see this. So turn that one on, turn this one. And as you can tell, it is an ellipse cylinder with the ellipse as your trace on the bottom. So, and it stays the same, even though to me it kind of looks like it gets smaller towards the top. It doesn't, it just stays. Okay, that's that graph. Let's deal with another cylinder. All right, this one, what we're going to do, let's first verify that it is a cylinder. 2 variables tells me that it is a cylinder. The trace is on the YZ plane. And then it is directed along the x-axis. All right, so here's our picture. We're dealing with YZ equals 1. Now, to me, I don't recognize it that way. This is the way I recognize it from algebra, is 1 over Z. And maybe it's been a while since you've done it, but it is 1 over Z. This is a rational function. These are the ones that look like this. If I had a XY plane, it looks like that. That's what 1 over Z looks like. So I'm going to plot that on the YZ plane. So this is flat. We're going to do our best. There we go. And then we also have it here. This one's really hard to see. And then it's going along the x-axis. So it's like coming out at us. So what we're going to have, let me try my best. Let's do this in dots here. All right, and then we'll have another dotted one down here coming out at us. We'll also have one up here. All right, and then we have the not dotted, and it gets repeated for each one. So we'll have one like up here, and then we also have one up here. So I'm just drawing that graph. matching each one. And we get like this weird, and it's going to be really hard to see on here. So let's do this. There's my line. This is how I get a parallel line. And then I'm going to move it to different parts here and maybe extend them. So there's my line. And we could just throw a few more on there. Try to accomplish what we're trying to accomplish, but it's extremely hard with this. And like for me, for real, like would have a hard time seeing what this actually is based on our picture, because to me it looks like a jumbled mess. What it is we have like almost like a quarter pipe there, right? Like from skateboarding on one side, and then we have underneath on the other. It's extremely hard to see. Let's jump over to our actual grapher to see what it looks like. All right, this one, just so you know, when you type these in, it's best to do z equals. So z equals 1 divided by y. This one typically will show up. So here we go. Let me get the spinning to stop. All right, so you can see how it should be. All right, let me turn it. That's what we're looking at on our picture, is something like that, but you can see it's like a steep wall and then it's underneath. So there is the feel of the graph. Almost impossible to see there. But we did get a feel of it. All right, this last one, let me move this photo up because we don't need to write a bunch. Let's do the cylinder part, 2 variables. Let's get rid of those. So 2 variables means it's a cylinder. Then we have trace is on what's there on the YZ plane. And then it's directed along the what's missing, x-axis. All right, so I'm going to draw the trace first, and then just think about it. Actually, we could probably do this. So it's z equals cosine of y. So I can graph cosine. We get, okay, and this is on the YZ. So I start here, and then I know, okay, I know the period's 2 pi, it's about 6. So we'll do it to here. We'll cut it in half. So here's half. We'll cut that in half, and we'll cut that in half. So what I'm doing is I know it doesn't go along the evens because our trig functions go along like pi over 4 and stuff like that. So I'm just trying to capture a picture of cosine. All right, so there is my cosine. I hope you know that. If not, I would get up on it. There's cosine. I'm also going to try to do it the same way on this other side. Goes down, follows the normal pattern for cosine. All right, what happens? This one's extremely hard to draw. Let me try to draw a picture for you. You could just think about it for a moment. And if you want to try to copy this down, you can. So I'm just going to plot this out here. And then I'm going to plot it again by just pasting. So somewhere out here. And what we get is we get these like lines that should be parallel with the axis. It's really, really tough to draw. So let me see if I can move things around. Okay, so I'm going to put those look pretty good. And then I'm just going to move that. There we go. Sorry for my moving around so much. There we go. All right, so now we get this. Let me do a couple copies and paste. And sure, we'll have, like I said, it's very difficult to see it on this. But what we get is a sine wave, like the ripple, but it's extended through the X. So we get this like big sheet, I think of a sheet metal on top of like a shack roof. Let me show you a picture of this. So yeah, we get the cosine wave. Here's the cosine wave, right here at the side, but we get it extended in the X direction. So this is what the picture should look like that we drew right here. Something like that. So extremely difficult to do in 3 dimensions. This covers the cylinder part of this lesson. As long as you know your conic sections going forward into the next one, you're going to be just fine. 3D graphing is very difficult. Please do not be discouraged if your picture looks horrible. Just do your best. The most important part is your first trace. Your first trace is what's going to show me that you know what you're doing.